codes and links. So if you can take a snap of this QR code, you will be able to see all the links here. So all the QR codes on our slides are basically a link tree which has linked to everything, the GitHub to RSPAC to ByteDance open source projects, our LinkedIn profiles, the innovator form that everybody has been asking about, and RSPAC GitHub also, if I didn't mention. So hopefully you can take a screenshot of this and then get to the links. So with that, let me welcome Zach Jackson. So he's the architect and for RSPAC, and I will let him do his own introduction and hear directly from him. Thank you.
All right. Yeah, so my name is Zach, and I'm an infrastructure architect over here at ByteDance. I work with our main infrastructure team, and basically just work across several of our products, I guess, our open source stack. So, from RSPAC through RSBuild, Modern JS, and of course, Module Federation. And I'm also the creator of Module Federation. So yeah, I'm gonna give a bit of a talk about some of the use cases for RSPAC and micro front ends, and kind of just a bit of an update on some of the new APIs that we've rolled out to Federation, and kind of the evolution that's happened over the past 2 quarters or so in this ecosystem. So let's get into it. All right. So pretty much, I think the big news here, at least in my ecosystem, is we rolled Federation support into RSPAC. In doing so, we've also given Federation quite a big upgrade after about, I don't know, I'd say about 4 years since I wrote the initial APIs. The biggest thing that we've really done in here is we've introduced this concept of like a runtime hook API and lifecycle and an SDK. So pretty much when I originally had written Federation, the only real kind of option that we had was writing it as a Webpack plugin. And so obviously when you build something as a Webpack plugin, it's a very specific kind of a build out, very coupled. So when we kind of wanted to introduce Federation support into RSPAC, and we're thinking about the longer term roadmap for Federation, potentially supporting other bundlers in the future, we kind of needed a new design that would be a bit more maintainable and centralized, so that we could kind of support features across Webpack, RSPAC, RSBuild, through the same kind of runtime. And so that's kind of what we ended up doing on this journey to supporting it in RSPAC. So I think some of the big things I kind of wanted to throw out there is, if we're looking at, say, the speed comparisons between like Webpack's Federation or just Webpack and RSPAC, generally what I've seen from just using the Federation examples repo and kind of migrating, I think there's about 350 projects in there. So it's taken a little time to kind of go through and refactor and migrate them all. But generally what I've kind of seen from it is, usually you can maintain around a 10x performance gain. I think the highest gain that I've seen when users switch is about a 17 times boost in build speed. But I think a lot of these things, you kind of have to understand the mechanics of like Rust and where the bottlenecks kind of show up in there, which has also been really interesting from like designing RSPAC and working with it and kind of understanding, and I guess as well just appreciating the API surface that Webpack offers. And so I guess one of the things, bit of a side note on it, but one of the challenges, I don't know if anybody else has experienced this, but I definitely did. And one of the reasons that I'd been such a avid Webpack user for such a long time was, really I couldn't find another build tool that had the same API surface. And as we kind of went more into the native build tools, I kind of saw the API surfaces shrunk as well. And after like working on RSPAC and understanding a bit more of the challenges around this, it's kind of obvious why this happens. I would say one of the biggest challenges really is the bigger you want to make the API, or the more like hooks you want to give to the end user, that all gets done typically in like JavaScript, create some kind of binding or API. The more calls you make to JavaScript, the slower it gets on like the native end, because the bridge between the two is not super quick. So that's kind of what shaped a lot of like native tools, at least in my opinion, is if we look at something like ES-Build, and I know ES-Build was not really built to be kind of like a Webpack, but one of the big kind of designing principles there were, they don't want to expose like the module graph or some of the internal mechanisms or the parser. And I never quite understood like why they didn't want to do that until I started working more with native languages. And it's actually really, really challenging to do that and still maintain the speed. If you're doing a lot of calls between the native and the JavaScript VM, you're paying a lot of overhead to do that. So actually creating a Rust-based tool that had a rich JavaScript API surface area, was more challenging than I expected, just because every time you add a new JS hook, how do you make sure that doesn't essentially just wipe out the performance that you get by going to a native language? So it's been very interesting to kind of see it come along, but I'm really, really appreciative that we do have a option that is a Rust-based or native-based build tool that still preserves the vast majority of kind of like Webpack's JavaScript hooks. So anyway, just a side note on it. But yeah, so generally what we're seeing is, if I look at any like example that I usually build out, we're seeing maybe like, 3-second build or something like that. And when we switch it over to RSPAC, usually that drops down to a couple hundred milliseconds at most to get a production build out. So obviously there's a huge, huge gain there. And I think some of the challenges around build speed, I think the challenge around build speed and why it's important, I think one, there's the developer experience of it, but it really does impact the iteration speed and how much time you kind of spend trying to build artifacts. And usually what I've seen, at least in my own experience and, before like working with Federation or things like that, you often kind of model what you're doing around the limits of how quickly you can get the artifacts out. So, I mean, a simple example I often see is there's old school releases where you would do, a release every like 2 weeks or something like that. And if you kind of dig down deep enough, there's definitely like process things probably in the company as well. But I've also seen a lot of it's kind of influenced by what their kind of infrastructure looks like to get the code out. And if your build pipeline takes about 45 minutes to run or something like that, you'll kind of see the rest of the process not be as optimized as possible because you have this 45-minute window anyway, so things can't really go quicker than that. And that kind of, puts a bottleneck on really what you can do. But if you can shrink that build time down to, a couple hundred milliseconds, or I don't know, I think that one of the larger projects that I've seen was 20,000 files, and I think it built in about 4 seconds. So that's pretty crazy to think about, at least from where I come from, working with a lot of JavaScript tools. When you get a production build out for a huge app in like 4 or 5 seconds, it really changes how fast you can push stuff through the build pipeline, but it also changes like what you can do and how you can experiment and how you could try to, just decrease the latency between change reflection off your machine and correction of it. So speed is obviously really great, but I think the speed on my side is really for, how could we bring down the cloud costs? How could we speed up kind of the business product iteration? Or I don't want to necessarily wait like 10 to 15 minutes for the next kind of reflection to show up off my machine. So anyway, kind of getting into it, generally, what we see across federated applications as well, the build speeds roughly stay the same. So I would say like, if you're porting from say a Webpack build or something like that, I would say you should, under any condition, you should get 5 times faster build speeds. If you are getting less than 10x, I usually suggest like reaching out to us on Discord or DMing me or something like that, because typically what I like to see is a 10x minimum gain. And if you're getting less than that, then there's probably something we can tweak in the build config or some kind of loader you might be using that's not necessarily needed anymore with RSPAC. The other really nice thing that I've kind of seen is we don't see a big performance overhead from implementing federation. I know this has been a challenge I've seen in some of the JavaScript build ecosystem, like with Webpack, is if you share a lot of modules or something like that, sometimes your build can actually be impacted by doing that. So what's really kind of nice seeing in here is I've seen no real impact when using federation versus just doing a normal build. So that was quite, nice to see after dealing with this issue for a while. And generally what I would say is most builds that I've experienced or worked with, and again, these aren't necessarily like building our big production apps, but through building examples or building things like that, most of the time it's under 200 milliseconds. I would say maybe on our larger applications, you'd be looking at a cold start of maybe 1 to 2 seconds. And that's pretty much it, and you're up and running. So it's a great experience, and I think even as it kind of goes on, I'm always still impressed by the snappiness of it. It's something that I'm definitely not used to. So one of the interesting things, I kind of want to dive a bit deeper in here, but one of the really interesting things that we haven't had a great opportunity to see or try, especially like in micro front ends or with federation, is kind of interoperability or migration or something like that. So one cool area I kind of wanted to focus this talk a little bit on is the ability to use the layer that is federation as a tactic to actually make two different bundlers work together in maybe slightly more creative ways than normal. So since we have the full interop between RSPAC and Webpack and federation, the same applies. They both will work just fine, and you can use them in tandem, together in any kind of way, shape, or form. But now it really gives you a nice, for the first time, it gives us a nice example of like, okay, well, how could you use federation as more of a migratory step, or use it to say maybe offload some pressure from an older build chain. And so that's kind of what I've got is like 1 or 2 slides just around, strategies of doing this. So the one kind of way is kind of like a progressive migration strategy. So just using federation as is, just to create this kind of bridge between the two. So, let's say you've got a couple applications that maybe they use like really exotic plugins, or they're just kind of, old, or just take a really long time to kind of migrate down or try to upgrade. But you still want to kind of modernize your build a little bit. What's kind of nice is being able to use RSPAC and Webpack interoperability, and be able to have some of these builds be RSPAC, some of them be Webpack, but at runtime, everything still works, as if it was built by one thing. You don't really notice any difference. So I have a small example in, I have a small example in here that's doing this. If you go into the module federation examples repo, I have a few. So most of these all have RSPAC now. So if you go into any of these, like automatic vendor sharing, you'll see all of them will have like, the start command. So if it's got a legacy one, that means that's Webpack, and then the normal one would be RSPAC. So, if you look in here, most of these have RSPAC config. So most of my examples, if you want to go and check out either one, they're both there. But the two I kind of wanted to focus on are the RSPAC interop ones. So the first one is this example that I usually go to, which is just this basic interop. So what we've got is 5 applications, and I believe how I had it set up is the first application uses Webpack. So I have an RSPAC config in there, but its build is set to just run Webpack. But the other 4 applications on here, I believe they are all set. Yeah, see, I have them as legacy build for that. So when I run start, it's going to start RSPAC for the other 4. So we can have a look at what that would look like here. Let's see. Yep. We can just start this. Oh no, what have I done? Of course I get hit with in app 1. Okay, hold on a second here. Offline. Darn it. Let me just remove whatever's wrong with my package JSON there. Okay, try this one more time, see if it boots. Okay, there we go. So now I have these up and running. So you see it started all 5. I still see app 1 here is busy booting. That's the Webpack build. There we go. Now it's done. But did you see how quick the other ones finished? So the other ones, 200 milliseconds, 130 milliseconds, 177 milliseconds. And then our Webpack guy up here, I don't know how long it took to start, but it definitely took a couple seconds. I don't see the timing in there. But, it's really interesting to kind of see that difference, even in such a small example here, the amount of time it takes to actually get it going. And, if we go to like localhost 3001, boom, you see, just like any of my other examples, something kind of pops up here. But what's kind of nice is, this is a mix. So I think this 3001 is an RSPAC build, or that might be the Webpack one. Let's go to 3002. And, all of these are then going to be your RSPAC builds. But you can see that even on 3001, I'm mixing and matching between different bundlers, and the application still behaves and works just like normal. So it's really nice if you have a couple of those smaller builds that you'd maybe want to offload. You've got a really smooth pattern to do so, where they'll just work together like normal, and their configurations more or less look the same. If you've ever worked with Federation before, you go into your Webpack config, and it's just the standard thing. And if you go to RSPAC, same deal. Nothing out of the ordinary. But this gives you a really nice way, again, to be able to offload these. You could have a shell that might be big, use some exotic hooks or plugins or things like that maybe don't work so well with the Rust ecosystem. And that's not really a limiting factor. You can kind of use both however you deem them necessary. All right, back into our slides here. So that was kind of just an example of gradual migration, or a one-by-one, or just using them in tandem for different purposes. The other example I have here is I kind of got the idea from how Veet does their dev server, and that would be using them together to speed up the bundling of Webpack. So one easy way to kind of speed up Webpack is, or this is kind of also the original reason that I'd built out Federation in Webpack, was one, I wanted a solution for kind of like distributed things. This kind of came from when I was working at Fiverr, and we had I think maybe up to 30 micro front ends per page at any given point. And it was all NPM based. So it was really painful that every time you have to do something, you have to wait for a bot to open a PR to kind of update the packages, so on and so forth. And that was obviously something I wanted to solve with an at runtime solution. But the other area that I kind of saw Federation really useful for was just as a way to speed Webpack up in general. So Webpack's pretty quick until you load it full of plugins and loaders and other things that slow it down. And then obviously the size of the code base has a similar impact on degrading speed. But if you can, so with Federation, my whole idea was, well, if the builds are never large enough to become slow, then you don't have a problem. And that was kind of one of the beauties of Federation. But with RSPAC, another kind of interesting option here is you can offload the heavier parts. So say node modules, that's an easy one. Node modules can chew up most of your parsing time, because that's usually where a lot of your weight is sitting, is in the NPM packages, not necessarily in the app code that you need to transform or whatever. That's typically maybe a few thousand files at most. But then when you add all your node modules in there, you really kind of see the slowdown start to happen. An easy way to test this is if you go into an app and you made all node modules externals and run the build, you'll see it be dramatically quicker than if you didn't do that. So the other example I have here is, kind of doing this exact thing, where we pretty much take our node modules and we tell the Webpack build, share them, but don't bundle them in. And then in RSPAC, we say bundle them all. So now your Webpack build basically doesn't do any work on node modules, and RSPAC can feed them all to it. So I have a basic example demonstrating that in here as well, and that would just be the Webpack RSPAC offload example if you want to play around with it. It's a very simple one, and I think I probably copied it from a different application, but the same kind of concept in here. Everything's Webpack and RSPAC as well, but I believe the idea is that the library application is going to be the RSPAC like based one, and it's going to feed everything into, say, maybe the main app here. And if I go and look in my main app, you'll see really basic again, but React is set to import false, Lodash is set to import false. And when you do that in Federation, it means that this build will treat these libraries almost as externals, except instead of like normally when you do an external, it'll maybe look for the window or something like that. When you set it to false through Federation, it does a similar kind of thing, but what it's directing it to is it's saying you need to ask ShareScope to broker the dependency for you. So it's not just look on the window, but it's like look at ShareScope, and then based on whatever Federation's package sharing resolves to, I'll pick that, but I don't have anything to actually contribute here, and I won't spend the time bundling any of that stuff in. And so, what this kind of gives you is, again, if we boot up an example here, it should give you, a much, still same outcome when we look at it in the front end, but all of our node modules will be delivered from, let's see which port it is. Yeah, very old example here, but basically all the node modules this thing is getting are coming from RSPAC, and Webpack doesn't actually have any node modules to vend in here. And I'm getting everything shared through kind of like almost a library build that I've got, all of these guys. And so all of this comes from RSPAC, and that's from RSPAC, but my main app code is still from a Webpack base. So again, it's a really kind of nice way to be able to offload some of the work in a more creative manner. And I think these are two cool kind of things to demonstrate, because I don't think we've had the ability to really mix bundlers quite like this before. Usually either have to reparse or recompile them or, something, but you can't use two different build tools to kind of snap an applet. Maybe with ESM import maps, maybe you can do it there. But in general, bundlers don't really like play nicely together at runtime. They have to go through their build processes again. So these are just two basic examples kind of showing a really cool way of utilizing the two bundlers together, and not just your standard use this or use that kind of scenario. And this is kind of what I like about Federation too, is you have that kind of flexibility that at runtime will do the final piece of stitching the code together, and then at build time you can build out creative architectures or different architectures, and kind of lean on the fact that these two bundlers are designed to snap together at runtime and work with each other just fine, with this kind of using Federation almost as like a transport protocol. So anyway, back into my slides here. So yeah, doing node modules, another great one, easy kind of solution, just offload pressure from Webpack. I don't know if I would use this in production a ton, but I think this would be a really cool thing to use in development mode, similar to how like Vite does it with ESBuild offloading all the node module bundling from Rollup. So similar kind of idea could be done here. All right, so then the other option is you could do something, say, like a step-by-step migration. So kind of what I would suggest using is we've released Module Federation /enhanced, and that is pretty much what RSPAC uses. And then if you are Webpack build, you would install this package, the Federation Enhanced one. In RSPAC, that's just the default. We also still export out a class called like Module Federation V1, and that is the original Webpack implementation still. But by default, it's going to use the enhanced one. And most of my examples have migrated over to using enhanced. And again, when you switch over, you just change the import, install the package, and keep doing your thing. So there's no breaking changes between this, but if you're going to try to connect between the two, I would say using the enhanced layer is going to give you a lot more control out of it. But using that, again, now you can migrate them however you want. If you wanted just button to be updated, it gives you a very low barrier to entry for trying out new things, or trying to change the build ecosystems at a company without needing such a huge ask. If there's header, you could just do header, and now header is going to be much quicker, but that doesn't really cascade any risk down to, or put any asks on other product teams or whatever. And there won't be any real noticeable difference from somebody consuming your module if you switched it over. So again, I really love this kind of strategy of using federation as a way to be able to kind of step into different tools without having to kind of pay that price of retooling, or just anytime you want to switch out a bundler, it's never a quick job to kind of go and do. So then the other area I kind of want to speak about here is a big piece that we've added to federation, which is this concept of runtime plugins. I've been really excited for this because I've tried to build this once or twice before and it didn't really go super well, or I guess it was just really difficult to do. But one of our teams here at ByteDance, we have a project called VMOC. And so what VMOC is it's essentially kind of like a discovery service for micro frontends. Whenever we serve whenever we would serve an application or an environment, let's say, when it's running with VMOC, what the environment really is it's actually just a module snapshot. So think of it like a runtime lock file. And since federation is totally dynamic and all these bits and pieces that we want are technically deployed all the time, a production environment or a staging environment, or basically any environment, is really just this snapshot or lock file payload. So once we send the lock file from VMOC and federation reads it, it becomes whatever the application is. So you change the payload and your environment is now whatever you want it to be. So if you want it to be production, it's technically just a JSON schema. And that's the only thing that keeps this environment as production and this environment as stage, is really kind of this this VMOC payload that does it. But one of the really cool things that came out of building VMOC is to kind of do these things, we really needed a lot more fine-grained control. And so that's where Federation Enhanced kind of came from, is we pulled the core of VMOC's build plugin out, and we've refactored it and kind of rewritten it and enhanced it, and that's what Federation Enhanced is. And originally it was a fork of Federation as well, so we haven't really gone in and re-engineered or made any breaking changes, but we've just opened up some kind of flaws that I might have seen in the original design of how I had built Federation before. So now what we've got is we have these runtime plugins. The plugins basically allow for, one, fine-grained control. Two, they give you a life cycle that you can use for different kind of events that might happen, or just to control the flow of what's happening in the code base. I think a big thing that I kind of wanted to try and build out with the runtime plugins was almost like a express middleware style. So when I originally created Federation, I think the big thing that I thought the problem was, the thing that I thought the problem was is, I want to be able to dynamically import code from somewhere else. And I mean, that's technically true. That's what I wanted. But a couple years on, in hindsight, it's dynamically importing the code is definitely something you need, but there's more issues that kind of come from this. So once you can just load code from anywhere, then you kind of need a life cycle of some kind. And so really, this is, I think, how what I should have done the first time around, and I'm happy to kind of go in and correct this, is to give this layer of control to the users so that, if, say, a remote is offline, how would you recover from that? Or if you don't know what the remotes are up front, you need to pull them from environment variables. There wasn't really a lot of dynamic control to be able to do anything like that in the original plugin. And so the runtime plugins really come in here and they allow you to inject whatever you want into most life cycles that happen inside of Federation's runtime itself. So just to give you a kind of brief look at a simple plugin, if I were to go and create a runtime plugin, this is more or less what it would look like. There's some other hooks that we have in there, but generally this is a good kind of breakdown of it. You've got before initialize, which is essentially if any of you have used Federation before, Whenever we connect two runtimes together, the first thing that we do is we kind of initialize them, and this is what creates the module sharing object and singletons and things like that to happen. And so, and it's also async, which is kind of nice. So we've been able to introduce these kind of life cycles into various parts. So before something initializes, you could put an async function here and say maybe reach out to an API and say, well, what are the remotes for this configured location? And now you can append the remotes that you want on here. Like if you're in production, maybe the URL to these micro frontends are different than you're in your staging. But this has always been kind of tricky to do well in Federation because it's very static. But with this interface, it's not anymore. Before request is a similar kind of concept, but it really happens like right before the import is made. So if you say import app2 button, before request, the arguments in here would come back and say like, hey, it's going to app2 and it's going to request button. And if I wanted to say, redirect the request and say, well, I don't actually want button, I want like green button, you could just mutate the arguments and say, okay, well, it's still app2, but the module I want to pull off of it is going to be, green button. And then it will just continue on, and basically you will get a different module for what you were asking for in the import. After resolve is kind of useful. I don't think anybody will use it a ton, but really what after resolve is kind of for is that hook fires when it says, I found the container you're looking for. So if you put in app2 /button and app2 isn't loaded, this hook would never fire. But if it sees, oh, okay, well, I can access app2, after resolve will happen. So it's kind of useful if you're trying to see, like, I need to go and blindly find something. Does it exist or does it not exist? And before request will be, I don't know if it exists yet. After resolve means I know the container's there and I can access it. So you can, technically use these either way. I think most of the time I just use before request. Onload is quite useful as well. Kind of the idea behind onload is once I do an import and I get module exports back, sometimes I might want to wrap them in something. So what's really nice about onload is I use it in a couple different ways, but one of them is if I return a function here, that will be the module exports that whoever's importing gets. So if I go app2 button and I have onload and I return, say, like an arrow function with JSX, I won't actually get app2 button. I'll get whatever I returned in this hook. Or the big one that I really use it for is, let's say I want to wrap everything in error boundaries. So React error boundary around all components. With the onload hook, I can say, cool, well, whatever the user was doing, pass that through, but return it in some new JSX error boundary original requested component. And there you go. You can kind of create these wrappers or proxies around the functions going back to the user. And load share, again, if I'm loading shared code or anything like that, these hooks will fire off as well. So you have, again, these life cycles that you can control around who gets what, where it's going, what is it you're actually getting, so on and so forth. If we look at an example of using or how you would actually use a runtime plugin, if you're familiar with Federation, same kind of setup. The main real difference that we've added is there's just a new key called runtime plugins, and it'll accept a array of file paths if you do it in the build plugin. But we also have a package called module federation /runtime, and that's what actually runs everything between Webpack and RSPAC now. And you don't need the Federation plugin to use the Federation runtime. You could do it completely dynamically, and you can still use runtime plugins, and you could still set up shared, and you could, I think the only thing you can't do is expose things, because in order to expose stuff, you do need like a build to create a file. But if you were trying to consume things or do anything like that, you can just use the Federation runtime dynamically as like a library. Or if you use the plugin, all the plugin is doing is really initializing that runtime library for you. So if we look at a practical example, this is a really nice one. If you've ever worked with Federation or anything like that, one of the big challenges is what happens if something isn't available or it's offline? How do you recover from it? How do you not break your main application? And this has always been really tricky to kind of safeguard against. Usually when users ask this, I'll say, okay, well, use a dynamic import and you can, catch the promise. And that absolutely works, assuming the developer using this remembers to wrap it and catch it accordingly. And secondly, as long as Webpack can still resolve to like the base part of it. So if I put a dynamic import for app2 in and app2 button doesn't exist, I can try catch that, dynamic import dot catch, no problem. But if app2 doesn't exist, that won't work because the Webpack runtime or the runtime actually crashes higher up. So I can't try catch anything because there's no like base interface to connect to, and it throws a a module graph error and crashes your application, in a non-recoverable way. Or if you say used import from instead of a dynamic import, how would you handle an offline remote there since there's no async lifecycle to kind of catch on? So anyway, so this is a nice kind of example of it. So here's what it should look like. When I take down app2, this is what ends up getting rendered. Remote 2 is offline, blah, 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 but the application is still functioning. And so how we actually implement that in a runtime plugin is, quite trivial, especially compared to what we've had to do before to try and do this stuff. It was, near impossible. And now, this is a couple lines of code. But basically what I'm using is this error load remote hook. And when that gets fired, I basically just create like a new kind of a function that I'm going to return in the event. In this case, it's like, a little kind of React component where it just, renders a string telling me, what failed and what the error stack was. And then I have like a little helper here, just in case it's like ESM or some loaders in Webpack or RSPAC can evaluate the code as they're bundling it. And so in those cases, sometimes you kind of need to have a marker on it or whatever. But basically, I just have this Git module to help me normalize between the two different module schemas that might exist. And then again, really it comes down to, similar to onload, error load remote, if you return a function from it, it will return that as the module exports from, the application. So if something fails, I can just return my own component. You could also do this as like a dynamic import. So let's say you want to get header and header for whatever reason fails or isn't online. You could say, okay, well, my fallback is going to be, and you could just dynamic import header from NPM and like get a stale copy off of NPM. And that could be your fallback case where, hey, I guarantee it'll work because I'll bundle a copy of header in, but it might be old and primarily reach for the online copy. And if it's offline, just return a stale copy that maybe gets updated once a month or something like that. All of this is much easier to do in these kind of runtime plugins that we have set up. So this is really kind of the exciting part of it. And I do have a couple demos. If you look in Module Federation examples, repo, there's a folder called runtime plugins, and that's kind of where I'm trying to collect various examples. Most of them are more advanced, like how could you change sharing priority and say, hey, I want to use React 16, or I want to use React 16 from app 1 and React DOM 17 from app 2. How would you be able to control that share resolving yourself instead of Webpack kind of magically does it or the runtime magically does it? But I have examples in there showing you how to like prefer shared modules based on relationship or other various things or flags or whatever you would kind of want. So I would definitely check them out. It does introduce a really nice dimension of new capabilities into like how you can control distributed systems. So what I kind of wanted to do is just speak about some of the other tools in our ecosystem and how they fit together. So some of the big ones, really, I think we've already spoken a bit about RSBuild, and the other two I kind of wanted to showcase is we have something called RSPress and we have something called RSDoctor. And all of these tools are really, they're all kind of built off the Rust RSPAC style thing. But, they do introduce, again, some other kind of things to help fill out, I don't know, just general problems I've run into at larger scale web development. So the first one, my personal favorite, is RSDoctor. If any of you have ever worked with like stats or, bundle analysis, it's really useful until it's not. And usually when it's not useful is when the build gets really large. So in many cases, I'll find, okay, I can see there's a lot of bloat in the bundle, and I can see that it's this module, and I don't know why it's there or why it's coming in. And actually finding that can get really difficult, especially if you're I don't know, we have like a lot of apps here that are, 20,000 plus files. And at that stage, it gets really difficult to understand what's going on. So RS Doctor kind of comes in here, and this works with RSPAC and Webpack. It's just a plugin. So if you use any of those, you can kind of tap into this. But what it does is it gives you like, a sane way to look at build stats and times and sizes and, other types of information. So, in the overall view, you kind of could see what's our compile times. And, I really love this because you could see, well, what's actually taking the time up, what's eating into my build, what's the overall size of the build, and what's the breakdown of that. And, what was the builder that it was built on. Some other views that we kind of have in here, if you're looking for total sizes, so on and so forth. You can break into the bundle analysis, see kind of every chunk, what type of chunk it is, and you can go and kind of explore the module graph and see like what each individual module is that kind of came in to each chunk, which again, very nice to kind of have on hand. We also have other views like, our loader analysis. So this one's really, really cool because again, this is really difficult to find out, but what's taking up build time? And if it's a loader, how do you know where the problem is? So what's really neat in this view is you can kind of go in here and see, okay, well, it took 21 milliseconds for loaders to process layout TSX. And I think if I click into one of these files, I'll get the full breakdown. But for right now, it's just showing me like the directory. But in here, you can see, okay, well, our Babel loader took, 4.8 seconds to run, and post CSS took 300 milliseconds, and so on. And now you kind of can get this breakdown of where's a bottleneck that might be in my build that's typically not necessarily easy to see. The other kind of cool tool that we've got here is RSPress. And so this is really just static site generation, doc sites, basically anything static that you'd want to output. Again, built on RSPAC, it's all like Rust oriented and so on, but it's kind of geared toward doc generation. So if you look at any of our tool sets like RSPress, RSPAC, pretty much all of them are all RSPress based sites. Just to give you an idea of kind of like what it looks like and how you can use it. So I've really enjoyed that, especially keeping it in the ecosystem and kind of having something that's, more or less got the things I need without too much fragmentation getting introduced. RSPress is, quite useful. I believe I'll be switching over Module Federation's docs this quarter to use it as well, which should give one, more information and use cases, and two, just like a better reading experience for the users. The other one that we've got, we briefly touched on this, but this is RS Build. And so if you're looking for really what's the difference between, say, RS Build and RSPAC, the easiest way to put it is not everybody loves the Webpack style of configuring builds. I think this has probably been the way I see it. There's two big negative points that like Webpack has historically had. One is maybe speed is starting to become unfavorable, but the second that I've usually run into is configuring it as an acquired taste, and it's a little bit more complicated or verbose than maybe we would prefer in this day and age. So obviously with RSPAC mirroring Webpack's APIs, we're not necessarily going to we're not trying to stay limited to that configuration style, as some users might not want that. So RS Build gives us, for lack of a better term, it gives us like a good kind of like a Vite style experience for configuring builds. So, it uses more of that like define config style configuration, and it might have like a React plugin, and that React plugin would say under the hood, configure several different parts of the build for you. And you just need like a handful of lines of code to do it. And, most of the verbosity, like, chunk splitting or optimization or which loader to apply where, a lot of that you don't need to really think about, and it kind of just more or less works out the box. I mean, there we go, batteries included. So that's really kind of what sums it up well. So it's definitely a nice option if you're looking for something where you might still want the power of like a Webpack grade compilation, but you don't necessarily want that power in front of you all the time. So RS Build is perfect because you can always hook into the lower levels, but you don't need to unless you need to. So one of the really nice cases for RS build that I've used is we have some examples in here using it, but the main one that I've used it for is Create React App to replace CRA. So CRA has kind of been painful to support with Federation. You usually have to use either like Rewired or Krakow or something like that. But with RS build, we have a guide that shows you how to just like one-to-one like migrate, and it usually takes maybe like 10 to 15 minutes, and you can switch off of Create React App and onto RS build without really needing to rechange anything. So this was a Create React App, and now it's RS build, and that's it. That's all the configuration that I need. And even now in 0.5, we don't need this either, and it also supports Federation built in. You can just pass it tools module Federation, and kind of check our docs there. But that's basically it to kind of switch over. So again, I really like RS build because it just streamlines it. There's lots of times where I want to build tool quickly and I don't really care about anything other than like, here's my file, it's React, just make it work. And this is, again, a really nice kind of refreshing option to have without having to like switch to a different ecosystem just to get like a more streamlined build setup or have to like roll your own. All right, and then I think I'm getting toward the end here. Yes, so basically, those are just some of the areas I kind of wanted to go through. I know I kind of sped through it quickly, but very high level. These are some of the big tools that I've been excited about, how you can kind of utilize them. If you're looking for any specific resources, anything to do with Federation, I would say two really good packages to go and look like are going to be under my Universe mono repo. And inside of Module Federation Universe, it would be the enhanced package. That's going to be the new Federation plugin. If you're using Webpack, that's what you would look toward. And then the runtime package, which is essentially everything that was inside of Webpack as JavaScript is no longer in Webpack, and now it's a NPM package. So Federation is not really coupled to a bundler anymore. It's more of a runtime, and we have bundlers implement this runtime or initialize it for us. Federation examples, obviously a good resource. And then if you're looking for any of our kind of like RS family things, we've got RSPAC, RSPress, RSBuild, and RSDoctor, and they're all, .dev domains. And then if you do want to join in our Discord for anything with RSPAC or anything with our kind of ecosystem, or you just want to get in touch with me or anything like that, our Discord is always a good place to go to find like-minded individuals and to, get hold of the team. If you need some support or you're stuck on anything, we generally try to be quite responsive to users. And if it's a really large project or a large company, we do try to create like private channel or something like that, just to give some privacy to the big users and give them like a dedicated space to kind of speak and get some support. So yeah, we'd love for the community to grow, and we'd love to see some more individuals adopt either RSPAC or try out the new enhanced Federation if you're already using Federation, or you're interested in kind of distributed systems and so on. And that's really, I believe, that's all I've got for the keynote there. But if we have any questions, which I'll go and now check the chat. Happy to spend some time just going over questions. Okay, let's see. I'm just trying to scroll up in here and get to all of our questions.
Yeah, quite a few questions, Zach.
See, this is the problem with the screen sharing, is whenever you share the screen, it's because it's going to put it in presenter notes, so you can't like see the other thing unless you have two monitors, and it's so hard to do on a laptop.
Yeah.
All right, trying to scroll through these and see.
Yeah, well, Zach C has been answering a lot, so.
All right, let's see here. So yeah, Vite, kind of what we're doing is we're waiting. So Vite has a Federation plugin, but you're probably thinking like the Origin.js one. That is still like what I just call like it's the V1 Federation. So taking whatever Webpack and I had created like 4 years ago and kind of trying to mimic it and keep the interfaces somewhat compatible. But what I'm hoping to do is with roll down coming along for Vite, we could then have the chance to kind of build, I guess, or they have the chance to build like a proper build tool and not kind of be stuck with some of the limits that they've had currently. Like, Common JS is really tricky to do in rollup, where it's not kind of built in well. Or code splitting is also like, hit and miss sometimes. But with them introducing roll down, I think we'll have a good opportunity. And Evan already has been like quite a fan of federation from our discussions. So there's a lot of alignment on, hey, when you get a bundle that you have more control over, how could we integrate these things together? So timing on that, I would say probably second half of the year, just because there's bigger priorities for the roll down project that I know of. But once they get to that point, part of my design with the Federation runtime and why I created the Federation runtime SDK, and then the piece for Webpack is we call it the Webpack bundler runtime package, and that's essentially the bindings to the bundler. So maybe I need Webpack require this and that. That's what bundler runtime is for. And the enhanced package just instantiates the runtime, connects the bundler runtime, and interprets the options. So the idea behind the design, though, was, well, to support RSPAC, we needed a way to not, write like straight Webpack plugins, but more, write something that's a Webpack plugin that injects just standard JavaScript runtime code. The main reason is so, hey, if we want to support other bundlers, it's not a mission to do so. It's kind of designed thinking that others will come along. Another angle that I do want to look at doing, and if anybody wants to help me with this, I'm happy to start a discussion about it, and I'd love to see it happen. I just don't have the capacity right now. But the way it's designed, the runtime should be able to support what everybody kind of calls, native federation. And native federation is, kind of using import maps and ESM. So right now they haven't been compatible with each other, but because of this new runtime design, I think I'll only need maybe like 5 or 10 functions to get added. And we put in an ESM shim and so on. And then the way the rest of the runtime works is it's not really going to care. As long as it can get an object that gives it a reference to something, it would work. So I'd love to introduce import map support into the Federation runtime, which would then offer module federation kind of as we know it, as an agnostic tool where you could just use it similar to how we would use single spa with their shim. You could either use it like that, or it would have kind of these accompanying build time integrations that could maybe would definitely offer maybe a bit more fine tuning or a bit more capability, just because sometimes you do need a bundler to handle, like, Federation and Node.js. You got to have a bundler to do that because you need to augment what Webpack thinks its file system is, or something like that. So some areas to really kind of get to what I would call maybe like a tier 2 or tier 3 implementation, you need a bundler plugin. But I believe that there's a really large surface area on what we can do with just like native standards. And since we have the runtime built for this stuff, it'd be great to say, hey, you can build some with import maps, some with maybe a different flavor of federation, but you have a single runtime that can kind of handle all of this. So that's what I'd love to get to with it. All right, let's see. Any other big questions here? Yeah, so again, looking to make it more native. If anybody knows ESM or import maps or works on it, I would definitely love to collaborate with somebody on that to get the import map, somebody who's worked with import maps more, because I mostly work with like this own design. So just a bit more to kind of understand there. Yeah, we do have NX. Yeah, NX works with RSPAC. There should be some like built-ins there already for it. Just kind of scrolling through here. Persistent cache. Okay, I see that that's a big one. So yeah, persistent cache for RSPAC. I know that that is on the way. I believe right now, so I know like roadmap wise, I believe currently we support over 75% of Webpack's APIs, or past 75% of Webpack's ecosystem tests. I think we were thinking by June or July, we'll reach RSPAC V1. And V1 pretty much would mean we've reached, the higher percentile of passing ecosystem tests that we can perform. So it might not be 100, but it'll probably be in the 90s. Just because there's some things like exposing the module graph would require sending gigabytes of data between JavaScript and Rust, and it kills the performance of Rust. But I do know we have things like persistent cache that we're definitely looking at doing. I believe it's already in the works. Some things coming up post V1, we're looking at like better RSC support. So I know something that Turbo did that we're gonna do is the ability for RSPAC to output multiple targets in one compilation. So like being able to build a web client and common JS server build without needing to run 2 copies of the bundler, but just, hey, build and output targets, web, worker, whatever else, and it just emits multiple build targets at once. So I would love to kind of see that. I see some things around the chunk graph API. So chunk graph APIs are going to be tricky. I would need to know a bit more on what you're thinking on the chunk graph stuff, but some of it is there are some workarounds depending on what you're trying to do and the extent you're trying to do it at. But if you're trying to like go into a chunk and like parse its module ID, or well, that might work. But if you're trying to go really deep into the module graph, we run into the issue of again, like to transfer all the graph data out of the Rust side and back to JavaScript and then serialize it and send it back. You run into the same problem we found with, trying to use SWC and Webpack as its parser to replace Acorn. SWC is much quicker, but as soon as I have to call JSON parse, it goes from being 10 times faster, or I think it was about 4 times faster than Acorn, to twice as slow as Acorn. And so it's super quick, but that calling of the parse, makes it slower than just leaving it in Babel, which is why either, that whole graph piece had to be in Rust or just leave it in the main thread because it's cheaper than trying to do inter-process communication. So this is still a challenge. And depending on what you're trying to do with that chunk graph API, some of the things we can do, but again, if you're going really deep into the module graph, there's just limits on what we can expose to JavaScript without, essentially making the build as slow as a JavaScript-based app, because chunk graph is called for everything. So if you're tapping chunk graph from JS, that means that Rust can only go as fast as it can send it back and forth, which is, again, going to impact the performance quite a bit. But if you're doing things like chunk splitting or other certain angles, I really would need to know the use case to see like what or how we could help there. All right, are there any other ones? Custom pipelines, hosting, and versioning. Yeah, so I think at ByteDance, we have maybe 6,000 micro frontends, and then I think in total, one of the big challenges, or one of the big things we were doing with RSPAC was the reason for its design, or the rationale was, I think we have, last time I checked, we have about 17,000 repos that are all front-end repos. And so one of the big like limiting factors for the infra team is the cost of operations or the cost of change. And so Webpack's design one is really, really robust and could kind of do anything. We couldn't, I think the only other tool we found that had like ample API surface was Parcel. But the only reason that we kind of chose the Webpack design was 20,000 apps already use it, or 20,000 repos already use it, and this is a more cost-effective solution to kind of switching everyone over. But yeah, we have a large number of repos using this. I think, several thousand Federation ones. Then we have something prior to Federation, and there's several thousand more on that. And then those are all kind of moving over to our Federation one. The nice thing, though, is kind of with these new runtime plugins and the new Federation update and everything is it's been able to be tested at scale, which is really nice. It's something that's always been really tricky to do, is how do you, I don't know, when you have 20,000 applications, you can really flush out what's kind of needed for the business and so on. And so I'm hoping that kind of shows up in some of our upcoming designs and our new tools and things like that we're putting out. I know one of the things we're working on is like Chrome tools that just kind of help you see what's going on in the app, which is kind of nice. We have something called Module Doc coming out sometime soon. The idea with Module Doc is if you create a federated application or whatever, and let's say you expose button, if below button you put button.mdx, our build will see it and will automatically create like a federated storybook. If all you do is add an MDX file below the file you're exposing with the same name, a side effect of just you doing your build is we'll also produce a remote entry that stitches together a storybook. So every one that comes along, it would automatically generate, a discoverable like doc base for you, which is kind of cool. So I'm excited for that one to come out. Ken, does RSPAC support Rust plugins? I'm not 100% sure if we support it yet. I'm not sure. I know that it's been in the works. I haven't actually checked, to be honest. Let's see. I'm just checking if there's any other burning questions here that I've missed. If I have missed any, or if there's anything that I haven't answered somebody once, just send it in the chat again now that I'm at the bottom of the chat, and I'll be sure to answer it. Okay, SSR, I see here, SSR delivery, modern.js. Okay, yeah, so I think just a note around SSR. Oh, and HMR, that's another really good one. So HMR, yes, we have HMR working internally for Federation already. I believe we are dependent on one or two other things open sourcing before we can actually do that. I believe one of the big ones was the data manifest system that VMOC uses. There's currently a pull request open. If you go and look for just like manifest in the universe repo, you'll see the PR. That introduces VMOC's data plugin. And so that's kind of what generated our module snapshots, and that's what runs a lot of our Chrome extensions and blah, blah, blah. And I'm pretty sure that's also what helps us feed one TypeScript remote type. So yeah, we'll get much better remote type support. I'm not sure if we'll build it into the plugin directly or if we'll offer it as like an add-on. Still like figuring out if we want to just wire it directly in or not. But we'll get TypeScript support. We already have HMR working the way you would expect it to, fast refresh as well. So that's 100% going to the open source. It's just a matter of time. I would say maybe, I'm hoping this quarter it goes to OSS along with like 2 or 3 other nice additions. I did see some things in here around server side. If you depend on SSR delivery with Federation, would you go with modern JS? And if so, how would you communicate with CSR? Okay, so there's a couple things here. So I think SSR from modern JS, so that's a big one. That again also depends on our data plugin. So I haven't been able to roll out SSR support in modern JS for Federation because we needed the data plugin to really do so, to know kind of what we need and to make it just kind of work how everything works internally. Now that we have the data plugin, I really, really want to get a better SSR solution up than Next.js for Federation, because Next is really, really difficult to support, and there's a lot of foot guns with it. And we don't have any of these internally. It's just a matter of getting it out there. How you would use it with something like CSR, I'm guessing you would probably, let's say if you were using Vite. Okay, so if you can use like the Origin.js plugin, then for SSR, the best thing would be to kind of in Webpack, I would use like resolve alias false and say like, hey, server side, just don't care about it. And client side, then have it kick in. I'd imagine you'd have to do something similar if you don't have a common JS build on the other end that can give you that server integration for Federation. Okay, import remotes. This is a nice one. How would you define shared dependencies if using import remote? Okay, let me just share my screen on this one because this might be a little easier to showcase. What I would do is, I think everything that you would want to look at will be under the Federation runtime. Let me just go to universe. Okay, yes. And then what I would do is I would read the runtime package here. So we've got this guy, runtime, and then this README here will kind of give you a good idea. So this is, again, what my enhanced plugin is implementing is this. So if you didn't want to use the Federation plugin at all, this is essentially what we do. Is that just inside of a Webpack plugin, but it pretty much does the same thing. But yeah, so you could kind of initialize things here. I believe we do have shared options. Here you go. So if you did want to do something sharing, this is kind of what it would look like. So I think one of the challenges you will run into is there are some limits when you don't have a build plugin in play. Like I can't split React into its own chunk. And in this mode, I could say, okay, well, the lib is an arrow function that returns what I've already got. If you did want this to be more like dynamic or more like how federation would work, I guess what you would do is you would probably use like a dynamic import in here and make this arrow be like a async import, and everybody's kind of initialized there. And then you would use load share to make it go through the federation broker to pick the right React to use and not necessarily use your own one. But this is kind of like what you would do if you're looking for anything to do dynamically. Even like if you want dynamic remotes, again, you can do this. But let's say, and I always discourage doing this because there are limits to basically if you want to have like lazy loaded remotes, there's a race condition that can happen where, let's say if I initialize it right now with app2, and now later on I can totally run init again with a different set of remotes and it'll just merge them together. The challenge with this, and why I usually discourage things like import remote or stuff like that, is how federation works is it looks over the array and it says, okay, here's all the known remotes that I've got. And when I run initialize, I don't let the first remote seal itself until we know that the initialization chain is fully registered. Because what happens is when we boot it up.
I'm sorry. So I didn't realize you were sharing the screen. I didn't add your screen to the stage. And some people need you to repeat it because I...
Sure. Yeah, no problem. Okay. Yeah. So hold on. Which repo was in? Okay. Yeah. So then
and just one thing, like because there I see people already dropping. Can I just like share the feedback form?
Go for it. Yeah.
Yeah.
Do that
So
first.
just give me 1 sec and then you can continue.
Yeah, for sure.
Okay. So hey, thank you everyone. So yeah, Zach will continue. Like I said, do you guys see my screen?
Yes.
I shared my screen, right? Okay. Yeah. So for those of you who were there in the beginning, you know that we represent ByteDance open source, and if you are a developer passionate about working in open source and you're familiar with the open source landscape, and hopefully today's talk has inspired you to work with RSPAC, we would love to hear from you. So it is a recognition program, and if you're part of the innovator program, we would love to help you. Of course, Zach and Zach C and other engineers from our team, Joshua and everybody else, will be available to work with you. But then if you have solid project ideas or proposals, there are project stipends available to you. And also we would be able to feature you in a developer spotlight like how we did today, Jack Chappell. So people have been asking about the links. So here are the links again. And I have pinned down the event feedback form. We would love to hear about what you thought of the webinar today. Please take a screenshot because I know in the chat, none of the links are clickable. So hopefully from your phone, if you take the screenshot, you will go to that link directly. The last one is about your interest in being an innovator and working more closely with us. The first QR code is basically a link tree. So that links to the RSPAC GitHub, RSPAC Discord, ByteDance GitHub, all of our LinkedIn profiles. So we would love to hear from you. I'll leave that here for a few seconds before I hand it over to Zach. So again, I'm Sujata Tibrewala, representing the ByteDance Open Source Program Office. And it has been a pleasure to host you today. Hopefully everybody got that, and I can't see the screen or anything. So okay, go ahead, take away that.
All right. Okay, so yeah, just recapping again. So basically, if you want to do things like dynamic remotes or inject things, or I don't know, basically if you want to do things more dynamically, the Federation runtime is what you'd want to go to. Now, when you use the Federation runtime and the Federation plugin, which I do in several cases as well for that bit of dynamicism, um, since Module Federation Enhanced is the Module Federation runtime, it just imports this package for you and injects it into Webpack. So if you import this thing, it actually just resolves it back to the built-in copy we already have. But you can also use it without the plugin and so on. But essentially, this is kind of what it would look like. So one, I can do init here, where cool, put in my Federation config. It also works with the plugins. And, I can go down here. I've got the shared stuff here. If I want to use load remote. So if you're using import script or import or remote from my Federation utilities package, all of utilities can be essentially deprecated. And instead, you can just use the Federation runtime, where we have load remote and we have, essentially the whole suite that's actually used in our plugin, and we just expose the same interfaces out to you. But here's an example. Here's me initializing it dynamically, and then I can go load remote demo app 2, or you can also load it off the alias. So it'll work with the name, or it'll work with the alias, depending on what you want. We also have load share. So if, say, you wanted to do sharing dynamically, again, like I was saying, these would probably be best as dynamic imports, just so that you can split the chunks. Otherwise, you're always going to be loading the host's React because it's eagerly imported here. But this is how you could, basically create share scope and pass it along is, you just use the lib key in the runtime, and then you can point it to a factory or function that returns it. And now, I can choose my React from like a local one, or, you could mix and match it. What's nice is if you use this method, you could say use this with Vite or whatever you want, because consuming remotes, you don't need any plugin to do it. You can just use the runtime for it. The only thing we really need, the build plugin aspect of Federation 4 still, is we need somebody to create the remote entry JS entry point that has the interface to connect to. But if you just wanted to consume or do anything like that, here's again, load share React. So once I've got React initialized, and if I had more remotes, again, the whole brokering which React should I use would happen. And then you would pull it out of share scope with load share. And then, when you're using the build plugin, that's what we do under the hood. When you say, I'm going to import React, all we're doing is somewhere in the runtime code is we just call that method and point it back, and it goes through the compilation and does this. So, again, in here, we're also going to be, with the data plugin that's on the way, we'll also be introducing the ability to preload. So now you can actually preload the remotes. Like, hey, I want, app 1 sub. And, I could say, well, that depends on this guy. So whenever we see that this one's about to be used, we could eagerly go and load the nested ones. And that's kind of what our data manifest does, is it helps give us all of that. And you can also choose the resource categories. Do you want to load everything, or just the CSS, or just the JS? Or do you want to load a certain exposed module eagerly out of it? Like, I want to get add from app 3, and I want to get all the resources associated with the exposed add module. And you could preload all of that ahead of time. Again, here's our hook. So again, if you have a runtime plugin, basic example of one, and that's how runtime plugins are initialized in the runtime, separately from like if you were to do it in the build plugin, but same kind of concept still follows through here. I do have a repo. Let's see where I've got this repo. Let me just go to example, or wait, it's in my code base. So if you wanted to say add more remotes, so this is the one thing I was kind of warning about, is we essentially seal all known remotes, and then that's what creates share scope. So if you're lazily adding remotes after the fact, you run the risk of, if the first set of known remotes has already sealed and initialized, we can't go back in time and mutate share scope after it's sealed in a remote that's already initialized. So the scenario where this happens is, let's say you have app 1, 2, and 3. And app 3 is got Lodash, and app 2 also has Lodash. And you go into the application, and the first screen you look at is, say, like app 1's page, and then it maybe has a button to app 2. that doesn't use Lodash, and then maybe you click on something and it lazy loads app 3, and app 3 adds Lodash and it gets loaded into ShareScope. And then you click back to app 1 and you go somewhere where app 1 is going to use Lodash now. Because ShareScope was already initialized for app 1, even though app 3 added Lodash to ShareScope when it was lazy loaded, the ones who are already initialized can't see that. And so you kind of get this thing where ShareScope can tear, and the ones initialized later have more ShareScope than the ones initialized earlier. So we've done what we can in the runtime to mitigate this, to allow as much lazy loading. And in most cases, you don't run into the same kind of tearing issues that we've experienced, but it is still definitely possible. That said, if you don't run into issues with, using import remote currently, and you're not getting any torn ShareScope, and you just want to see how to do it in, say, the more streamlined way, this is basically what you would do. The main factor here is that you want name to be the same. So if I call this app 1 and then down here I init later again, sometime in later in time, I'm going to add new remotes. So what we do is we go, okay, when I run initialize, I look at the name and I say, hey, does an instance already exist with this name? If so, merge the options together. So now I go, okay, well, hey, I'm still app 1 and I'm going to add 2 more remotes to it. You can do that, in a hook or wherever you want later in time. And then you could say, okay, now load remote, and you could say, more remotes, and it would work. And, everything would still kind of work the way you want. So that's kind of how you would do it, is you can just rerun initialize again. And if an instance already exists, we just merge the options together, which, is quite useful. Let me see if there's any other questions on here. So yeah, lazy loading, again, this is kind of the challenge. I would just say you can do it if it works, but it's just a risk to watch out for. Like, if you had something like React, which needed to be a singleton, and you have that weird condition where the later React is never loaded at this point in time, it can possibly, app 1 won't see that app 3 added it because app 1 has already sealed itself. So we can't live read from ShareScope beyond the sealing process. Otherwise, we could possibly overwrite memory references, and that's how you could get like multiple React hook errors, because now there's technically 2 copies of React.
So I have added Zach C and Joshua onto the stage as well, because they have been monitoring chats, and there are a few questions, I think, which are pending. I don't know if you've already answered them.
Zach, there's one that you'll love. It's the what I heard that Next.js and Remix are distancing themselves from Module Federation. I'll let you answer that first, but yeah.
All right, so I don't think Remix is distancing. I would say Remix is more the opposite, because so I don't know if any of you know Jacob, who works at Remix, Jacob Eby, but he was the guy that helped me write the Node Federation plugin back at Lululemon. And that's how we got Next to work. And so he was a big part in that. So he actually works on the Remix, on the Remix project now full time. And the nice thing with Remix is, I would say Remix isn't really distancing itself from Federation. Remix is distancing itself from bundlers. So what Remix wants to be, and that's kind of what, if you look at all the Twitters from, all the tweets from like Jacob or Ryan, you'll see a lot of what they say is like, well, Remix is just a library. It's a router with a render handler. And that's really all it is. Now, in order to make it easy to use, they offer some pre-builds. Like, hey, here's a Vite, build out. But really all it is it's, them giving you a kind of like file-based router pattern, and them just passing some JSON to their render handler, and then there's the router like normal. So Remix is really, really flexible. Basically, it's just React router that comes with a render callback. So, and like, I think the first POC we did for React server components that Remix did, they did it with Module Federation. So we had a RSC Federation POC pop up to kind of look at, because Federation makes these type of problems very easy to do, because you have this kind of async mechanism built into Federation. So if you need to go and find something dynamically, you usually have to do this with like manifests and JSONs and like a bunch of other tweaks to the build. And it was really, really easy to do with Federation. So it was kind of a cool way to test out like, hey, so how would it work? How would it look like? So yeah, I would say not distant. Nobody's distancing from it. Remix is just taking the approach of we don't want to choose the bundler for you. We want to build a library that's a router that has a nice server renderer. And that's kind of where the buck stops with them, which is great because now that gives us a lot of opportunities. I think even modern JS, our framework is heavily based on Remix, and we're actually talking with the Remix group now and trying to see like, hey, could we turn modern JS into just a hat that sits on top of Remix? So if you have a Remix app and say you want something for micro frontend specifically, you could just use modern JS, and all it kind of does is it just wraps the app in some extra infrastructure, but basically it's just still Remix, just with again, like Remix isn't a meta framework. So I think there's also a really cool thing in here where it's like, these are the tools to make a meta framework, and you could take an off-the-shelf one. I know we're working on like an RS build variant for Remix as well. But it's kind of nice where here's the parts to build something, and you're not so locked into opinions. So you've got a lot of freedom there, and you can kind of do whatever you would want to do. Regarding Next.js, I mean, I would say the relationship hasn't changed. It's still the same, pros and cons. Next is not necessarily designed for Federation, and doesn't necessarily take that type of architecture into account. So the challenge that we just get is as like Vercel does their thing, it's not necessarily going in the same direction as what Federation tries to do. Like I think Vercel is typically very much bigger, faster monoliths, which no problem with that. Look at like Rails or something like that. There's definitely things that are great for that, and there's still a huge reason for those type of things to exist. But it's just, I think inherently Next has not been the most compatible with this type of architecture. They want bigger single pass that's fast versus distributed and more unknowns that can kind of be dealt with at runtime. So yeah, the Next plugin works as best as the Next plugin can, and whenever we're doing things here, the Next plugin also uses the enhanced layers for Federation. So we solved a lot of issues by just writing a Next.js runtime plugin that's automatically applied to Federation. So I would say we'll probably get more choice in the future with like modern JS already works with Federation really well. We just need to add the server side parts, but we have open source the pieces we need or are about to that would let us add it, easily without like reworking what we've done internally. So a lot of it's just been a waiting game on like making sure we get the things open sourced in the right order, so that we can bring some of our internal capabilities out. And that just takes, time. Any other questions any of you guys saw that we should answer?
Yeah, I know it's already 11:04, so if people want to drop out, we'll understand. I know people have been dropping out, but yeah.
There's also the shameless plugin for the Discord, right? So Zach's in Discord, I'm in Discord, the whole ByteDance team's in Discord. So there's a lot of folks in there that can answer questions too. I think Joshua, you're in there too, right?
I'm in there.
Yeah, I'm also there.
Discord's a good place.
Mm-hmm.
Awesome. This was fun.
Yeah, so there's some more question. Where can I dig more info on Rust plugin?
Let's all contact me because something that I've been looking into as well. So we could talk about it.
Okay.
Mm-hmm.
Yeah, so I think this is Kenneth, right? I saw his feedback form. So probably I have his email.
I think it's going to get pulled up in public, right?
Sorry?
So we're not going to pull that up in public though, right?
Oh, no.
No. Yeah, okay, yeah. He's saying he's on Discord with @can. So yeah, we can continue the conversation definitely there on Discord, and we will be sending out follow-up emails with all the links and also the link tree, and also the feedback form again and innovator interest form again, because I saw some people said that they were interested in it. And some people asked if we will be posting this recording, and yes, we will be. This is all recorded, and we will post it on the Meetup YouTube channel, on ByteDance open source channel. And I don't know if Zach, Joshua, Zach C, you guys have some channel. We can just cross post wherever, right? Once we have the recording.
Yeah.
Yeah, I'll post it on Twitter. So anybody who follows me there, you'll be able to see there. I'll probably pin it to the top of my profile for a week or two.
Okay. Cool.
Awesome.
Oh, and maybe one more plug while I'm in here. I have headcount in the Seattle office for the infrastructure team. So if anybody is interested in working at ByteDance or working on the infra team or working with me and some of our team, can reach out to me on Twitter or somewhere like that. And, we can chat and see if you think it's a good fit. But I've really enjoyed working here. And, it's kind of, at least for me, it feels like kid in a candy shop. These are just some of the tools we have open sourced, and the, plethora of things that we don't have open sourced is just as fun and cool to work on. So I definitely give it a recommendation. So if anybody's interested, I'm always happy to answer questions and be as unbiased as I can.
Yeah, thank you. Because thank you, Zach, for that. Because I saw some people ask that question, not here, but in the submission, in their form submissions. So that really helps. Yeah.
Yeah, let's
All
not
right.
call them out though, in case their employers are watching.
I'm not taking any names. Okay.
Awesome. See you guys.
Okay. Thank you. Thank
Thanks,
you everyone
everybody.
for joining. See you guys later. Bye.
Thanks.